Alrighty, whoa. All right, welcome back to 105. All right, we're doing the echo thing again. Please stop. All right. Alrighty, welcome back to 105. So today we are talking about functions and computer fundamentals. So double the fun today. So this will be, I guess, fun. So far we have just been writing our entire program in main, which is not great, especially as we are starting to write more complicated programs. So we can actually define our own functions to help us organize our code and, hopefully rewrite code we can reuse again in the future. So the idea is to break your program into reusable parts, make things more readable. Typically, we're doing math, so that involves a lot of, functions, things that take inputs, produce an output. Also, hopefully, makes our code easier to read and saves you a bit of time. That printf function, everyone has used that function. Someone helpfully wrote that function for you so that whenever you write a program, you don't have to worry about displaying characters on the terminal yourself. You just run some code someone else wrote for you. So to define your own function looks exactly like main. In fact, when we did int main and then curly brackets and all that stuff, that was defining a function called main. That's the rule of C. That's the first thing that runs when I run my program. But I can define a whole bunch of other functions if I want. So to add a function, just use curly brackets after the prototype. We saw the prototype if we wanted to, declare a function called square root or something like that, other functions in the math library. So recall, a function prototype tells you the types of the inputs and also how many inputs there are. We also call them arguments, and the type of the output. And if you name an argument, you can use it inside of the function. So for example, if I wanted to create a function, there's two ints, one inside and one outside. The one in the inside is the input, and the other one is output. Yeah, for here, so this is a function called add2 that takes one input. Its type is an int, it's called x, and it outputs an int, is how we read that. So in this, you can name arguments and then you can use it in a function. So for instance, I have int x here, so I can use this x inside of the function. Its value will be whatever value I get from whoever uses this function, and it doesn't have to always be the same. So inside of this, I'll have a return. So a return is a way to get output from the function. So I do the statement return and then the output of this function. And that will end running the function and go back to whoever called the function. So in this case, I would do return x plus 2. X plus 2, well, x is an integer, and plus 2, that's an integer, so it's an integer plus an integer. So the resulting type is an integer, which matches our output type. So the result of this function would just be taking the input x, adding 2 to it, and that would be the output. So the order actually matters here. The compiler reads your program from top to bottom, but your code starts running at main. So the rules behind this is the function definition or prototype must come from before where you use it. So for instance, if I want to write that add2 function, I can do something like int add2. So again, it's a bit weird. Starts with the output type, then the name of the function, then parentheses, and then all of the inputs to the function given first by their type. So here I'll say it's called int x, and that is my one input. And then here again, if I want to return something from the function, or if I want to output a result, and I do return x plus 2. So now that I have defined my function above main, so the way the compiler again reads things are top to bottom. And this will be frustrating because, well, it will do some silly things, so we'll go over that. But now instead of 4, here I can actually use my function called add2, and I could give it, you know, the input 4 or something like that. So now I can use this function in place of just using the value, and the result of add 2 to 4 should be the result 6, right? So if I compile and run this, it's just called example, the result is 6. So in here, add 2, I'm giving it the value 4. So inside that function, what we say, whenever we have this from main, we're using our function, we say we're calling that function. So we're calling that function. The input is 4, and it's going to be seen in that function. We'll go over the details of it in a little bit and further lectures. X is going to be equal to 4 for running this function. So 4 plus 2 is 6. And because it's in a return, the output of that function in this case is going to be 6. So our result is going to be 6. So any questions about that? All right, first weird thing. So let's see what happens if I actually did not listen to me and put it behind. So if I do something like this, you can see my compiler starts getting angry. I got wet red squigglies under add 2. If I compile it, I'll probably get a not helpful message. So a whole bunch of red. It says failed to compile. This was my compile command, and it gives me an error in function main. Has some words we don't kind of know. So it says error implicit declaration. So implicit just means I didn't add it. It means the compiler essentially made it up for me. So implicit declaration of function add2. What that translates to in more plain English is the compiler doesn't know what the hell add2 is. So when it got to this line, it doesn't know what add2 was. Implicit function declaration means it would have to make something up in order to call that function. So remember, we have to declare things before we can actually use them. So in this case, if the compiler goes top to bottom, first line is include std.io or stdio.h. So remember, that will essentially just copy and paste the contents of that file there, which has all the declarations for like printf and other functions like that. Similarly, for stdlib.h, it'll do the copy paste, and then the next thing it'll read is nothing, then read, oh, main. This person wants to define a function called main, takes no inputs, outputs an integer, and then they use printf with string, and they call the function add2, and then the compiler will be like, oh, they're trying to use a function, I don't know anything about this function, which is very frustrating because it's right there. Like, it's just like, read 3 more lines down and you can find it, you stupid compiler. Why is this? Well, because C was made in the 70s. Computers weren't weren't sophisticated enough to go forward. They just read from top to bottom. If it didn't exist, it just complained. Yeah?
So my question is, what if we define the prototype at the start and then we define the function at the bottom of the board?
Yeah, so that is one option. So the question is, hey, if we have, you know, the definition of the function at the bottom, could I do like what I did for when we introduced our own declaration of square root, and can I just put it at the top? And the answer to that is yes, and that is how we could fix it. So if we wanted to, well, we know add2, if we just put the prototype above, we know that it outputs an int, it's called add2, and it takes one integer as an argument. And if we end it with a semicolon, that is a declaration. And now we can see the compiler is all happy. There is no red or anything like that. So now when I hit compile, it's perfectly happy. Yeah?
Is it bad practice to just define the function above?
Yeah, so the question is it bad practice just to define it above? And the answer to that is not bad practice. It's just up to you. So once you get more complicated, you'll probably have functions in different C files, in which case you'll probably need header files and all that stuff. But we don't do anything terribly big and complicated in this course. But it depends. For this course, you could just define it immediately. that's fine. Any other questions with this? So that is another thing. It just has to be in order. C just needs to know the inputs and outputs to the function before you actually try and use it. It is smart enough to figure out, hey, you know, what code should I actually use when I'm running? That's a little bit of a different question, but it just needs to know the inputs and outputs. Other little things that are more of a style thing here in the prototype, I don't actually need to name the argument if I don't want. I could just say int. I don't have to give it a name. Again, style thing. You should be consistent. So easiest thing to do is just copy paste this at the top if you'd want later, and just put a semicolon instead of that, instead of the curly brackets, and just do that. Kind of up to you. The only option, or the only thing you have to do is make sure that at least the prototype comes before main. You could put the definition before main also if you want to. Again, style thing. All right, any other questions or weird things we can do about that? Good. All right, so we can make our own functions now. So let's take a minute to think about this problem then. So let's write a program. Lots of exam questions here. If you have been on that learningc.org from the course coordinator Selma, that has all the practice questions that are taken from your exams, you probably see that this is a fun thing we like to do. Apparently, is get you to draw triangles and all sorts of weird shapes. So we can write a program to print a mirrored triangle of stars if we want. So we can think about how to do that without using functions initially and just try and, you know, come up with a good way to do this. So I'll leave you with a minute. I'll give you a minute to think about how we can do that so that we write triangles, or well, a triangle that looks like it's on the right-hand side all of the time. So here it's 5 by 5, so there's 5 rows, 5 columns, and in order to align all of the stars on the right-hand side, everything beforehand is a bunch of spaces. So here would be like 4 spaces and a star. Next line would be 3 spaces, 2 stars, so on and so forth. So I'll give you a minute to think about that, and then we can program it up. Yep.
Do you care what time complexity at all?
Time complexity?
Yeah.
I don't think we know what that means yet.
Like how long it takes, like how many loops I have inside of a loop.
So how many loops do you have inside of the loop? You can do whatever you want. Yeah, for this course, we don't care how efficient your code is. It's pretty much if it works, unless it takes like 30 seconds, in which case, that's bad. Basically, if anything takes more than a second in this course, you have messed up. Or you're probably in an infinite loop, more than likely. All right, anyone have any ideas for me? Yeah.
We have a for loop that it goes from the number of lines. So for
For int I equals
0, and then
0.
I is less than the number of lines, and then I increases by 1 every time.
Yep.
And then inside that you actually outside of that, I would want to define a boolean called like either like space or star. And then I'd have a while loop, like while, j is less than the num lines.
What's num line?
Or
3?
number of lines.
5?
And then we can just check if I is, and then check, basically we want it like to have a if statement where if the space is less than I,
What's space?
is space, sorry, if, or well we can have another, basically we just wanted to print out those spaces like up until it's it hits I, whatever I is, and then we can switch the boolean to this space.
All right, so here, so we want to print spaces until whatever I is. So easiest thing to,
Need to define a boolean.
yeah, so easiest thing to do is look at, so we want 5 rows. If we iterate 5 times, then you want I equal to 0 the first time. So I equals 0, I equals 1, I equals 2. So the first thing is, maybe we think about how many spaces we want first, right? And we want to relate it to I in this case. So here, we don't need anything. So for the first one, how many spaces do I need? And maybe I want to relate also, yeah, well, let's have a number variable called const int. Let's call it num rows. So we'll just give things a name. So how does the number of spaces relate to I? Yeah.
Just make I the number of spaces and then do instead of an increment do a subtraction. So it's minus I at the end.
So we start I as the number of spaces.
Yeah. 4. So you go from 4 and you go down all the way to 0.
Like here?
Yeah. And then the third, yeah, you go minus at the end.
So I must be greater than or equal to 0 here, right? And then I minus here.
Yeah.
Oops. And then what?
And then you want to define numbers.
You would print. No, never mind.
Uh-oh. Yeah. Woo, Jesus. Yeah.
So, what if our first for loop is for I is equal to 0, I is less than 5, I plus plus.
Okay, so we're reverting back again. All right, so here, so again, I is probably a bad name since we know what we're actually doing. We should probably call it row in this case. We have num rows, right? So let's relate it. So let's call it, I'll sub in right now. Let's call it row. And row is less than num rows. So typically your loops will kind of look like this all the time. So yeah, so row goes from 0 all the way to 4 in this case. Yep.
And then inside that, we have another for loop.
All right, so we have another for loop in here.
J equals 0.
J equals 0, all right, J equals,
It's supposed to be the spaces.
so yeah, so okay, so that's good. We're thinking here, so we could add a comment like, so first, planning this, we want to print the spaces, okay?
And J is less than 5 minus I.
J is less than 5 minus I, okay?
And J plus J.
Plus J,
Now here we just print F.
and it's not I, it's row, yeah. And then, whoops, and then we just print F,
A space.
just one space.
And then we make another for loop outside this for loop.
So another for loop,
And here, J is equal to 5 minus I.
J is equal to 5 minus I.
And J is less than or equal to 5.
Row, J is less than or equal to 5. Okay, so initially we have some fairly magic numbers here, right? So anytime I see 5, that should just be replaced by num rows, right? Because that's what I actually care about here. So yeah, let's change that first. Num rows. Oh, yeah.
You
What?
also need to add a new line outside of the for loops.
Yeah, and a new line outside of the for loops.
You could also do it with if statements. And just have the main for loop that goes up to num rows, and then have an if statement checking.
Yeah, yeah.
J less than or equal to that.
J,
For the last one.
J less than or equal to? That?
And I had like, I don't know if it makes a difference, but I just had I plus plus and J plus plus at the top.
J plus plus and I plus plus. We don't have I.
Or sorry, row plus plus and J plus plus instead of plus plus row and plus plus J. I don't
Oh,
know if it makes a difference.
that doesn't matter. Yeah, plus plus row, row plus plus doesn't matter. All right, well, let's compile this, make sure it runs. So what I call this print star triangle, print mirror. Ooh. Ugh. So that seems to work. So some of it might be slightly confusing, so let's break it down real quick. So here, we're trying to relate the number of, pretty much the number of spaces we need to print to the number of rows and specifically what row we're on. So in this case, if I equals 0, or in this case, well, let's call it row equals 0, and we know we're printing 5 rows, so we have num rows equal 5. Most of the time, you're going to want to relate the number of spaces to values you already know. So in this case, the number of rows is 5. I want to print 4 spaces this time. So it's basically just, I started a new loop that wants to print exactly 4 spaces. And here, well, the number of spaces is just the number of rows minus the row I'm going to be on. And you can sanity check this with just a few values. So first row is going to be equal to 0. So row is going to be equal to 0. So this loop is going to go, did we go too many times? No, we didn't. So this loop is going to go j equals 0 until j is less than num rows minus row, which the first time is just going to be is less than 5. So it's going to go 4 times in that case, because remember, it only gets out whenever that condition is false. And then we just iterate through. Each time we go through the loop, j goes up by 1. So this seems to get us the number of spaces we need. And most of the time, whenever you see something that's like inverted, you just take the big number and then subtract by whatever you're going by. So kind of inverting it like this, it's a very common thing you kind of do if you're counting things. And then we want to figure out basically how many stars we want to print next, right? So this was print the stars. And in relation to the row, well, in this case, if I start 5 minus row, it's a bit more confusing to think about it this way, but it works. So initially, in this case, j is equal to 5 minus row, which would be 0. So j is equal to 5, and it goes until j is less than num rows. So it goes until the very end. So the first time through, this will print exactly once. Second time through, well, we start off at 5, in which case this should be, get rid of the magic number, num rows minus row. So this would start at 4 and go until j is, again, greater than num rows. So go until it's 6. So it will print for j equals 4 and 5. That will give us 2 stars, so on and so forth. So this is one way to think about it. Another way to think about it is, well, I could just get rid of the other for loop if I really wanted to, and just do it with one double for loop. So I could actually give things a different name. So I could think about it in a different way, because if I look at this, every time through, I'm printing 5 characters no matter what, right? In the column, I'm printing 5 characters no matter what. And sometimes I'm printing a space. sometimes I'm printing a star. So it might be easier to think about that way to get rid of those 2 for loops and only have 1 nested for loop. So I could do something like int call equals 0. Call is less than num rows because it's going to be a square all of the time. And also in this case, maybe it's nicer for our numbers to line up. So here, if I want a number to match the number of stars, maybe I just start row at being equal to 1 and 2 and then 3. Maybe that's a bit easier because now that kind of matches the number of stars, right? So if I want to start at 1 instead of 0, I just have to change row equal to 0 and change this bound as less than or greater to. So I could do that. And now I'm basically figuring out, based off the row, should I print a, well, based off the row and the column, should I print off a space or not? So the first time when row is equal to, 1, right, I have to figure out, in this case, whether or not I want to print a space or not. So I would do like if, some condition I have to think of, else. And then here, maybe I want to, I don't know, figure out when I want to print a space versus when I want to print a star. So this will get me the right number of characters, but I'm not quite sure what my if statement should be. So it should be something that is true whenever I want to print a space and false whenever I want to print a star. In this case, I could think about the other way. So to do this, I can kind of think about the values, think about how they relate to each other. So when row is equal to 1, I have my column goes 1, 2, 3, 4, 5, in which case I want to print a space here, print a space here, print a space here, print a space here, and then in this one I want to print a star. So I want to print a star only in the case where when row is 2 and when row is 1 and column is 5, that it is some condition that is true. So in this case, this is what column is equal to. What I might also want to think about is what is like num rows minus column, like if I want to think about the opposite of that. So if I think about the opposite of that is going to be num rows minus col, and it's going to go from 4, 3, 2, 1, 0. And then I can try and relate that to whether or not I want to print a star yet. So this num rows minus col, if that is, in this case, it looks like greater than or equal to row. So in this case, row is 1, right? The first time through, I want all these to be spaces. So if I want num rows minus col, and in this case, it looks like if that is greater than or equal to row, oops, then that's when I need to print a space through, right? So this is num rows minus col on the bottom. If it's greater than row, so row is 1, it would turn all of these into spaces. If row is equal to 2, then, well, it would turn all of these into spaces, which is exactly what I want. And then same for 3, it would do this, and then 4, it would do this, and then 5, it would print all of them as stars. So this is another way to think about it. Whoops. Messed up my brackets. So if I do something like that instead and run it, I can see I get the exact same answer. There's more than one way to skin a cat. I could also flip the if statement, flip the print statements, and try and figure out a condition when to print a star versus when to print a space. Again, doesn't matter. I could also go back to that solution I had before where I figure out how many spaces I need to print and then how many stars I need to print and do it in 2 for loops. Again, for this course, doesn't really matter, whatever you are comfortable with. All right, any fun questions about that? Again, different way to think about it. Easier to just think about what the relations are between rows and the columns. Sometimes you need to invert things and just figure out what conditions. If you're always drawing a grid, easier just to figure out what condition you want to print a star versus what condition you want to print a space or something like that. Some of the questions will be like, hey, just always print, I don't know, like a box around the whole thing. So for instance, if I want to make sure that, I don't know, I made sure the entire thing was in a box, then I could add some more things. Like if I wanted to make sure the whole thing is in a box in this case, like I want to draw this and this, well, in this case, row is equal to 1 in this case, and for this line, col is equal to 1. So I could just add more conditions to my if statement and do some else ifs. So I could say like else if row is equal to 1, then also print a star. Again, not the best way to do that. I could also make a more complicated condition where I just put ors instead. Again, lots of different ways to write a program, but I could do something like this. So if I do something like that, it starts to get a bit hairy. Whoops. Oh, because I have them in the wrong order. Ugh. Okay, bad example. So, yeah, I would have to move these up here. So again, order matters because we do the if statements in order. So the first time it just checked if my original thing should print a space. Then if it was true, it just printed a space and then didn't try to evaluate any of the other if statements. So if I wanted to do this properly, where I make sure above everything else, I fill in this row and then the first row and the first column, I have to put them above everything else because if any of them are true, it will just run that statement and then skip to the very end. So if I do that and compile it now, I can see that, yay, indeed, I filled it in. And I could use that to draw, a box around the whole thing if I wanted to. Whole bunch of different if conditions. Again, thing that is common for exams and stuff like that. All right, another program I could write is I could write a program to print rows of stars using functions instead. So this, we already saw this before where we just printed, the left aligned number of stars. A lot easier than the other one, but we can do this using functions instead. So if I were to use it using functions instead, I could organize my code a bit better. So if I wanted to just do what I did before and then have the user input the number of rows, maybe I want to use functions so I can actually tell what I'm doing at a glance. So maybe I know that, hey, I'm printing triangles, so maybe I make a function called print triangles that takes as input the number of rows to print or the maximum number of rows to actually print. I could call it max row, num rows, again, depends on whatever you feel like. And then here, instead of just writing my for loop, I can just call that function based off the input. So I could call print triangles or print triangle and then give it the input I got, so the names do not have to match. So here, the number of rows I got from the user, I just called n, just because it's a short name, and then print triangle, where max row is equal to n. And then here, I'm kind of dividing up my program. So this is me trying to print all of the rows of the triangle, or just print all the triangles. So I might break it up into another part where in this function, I don't nest for loops. I just have one for loop. And then I'm concerned about every time through this, I print off a single row. So I could start off with, like I had before, for int row equals 1, row is less than or equal to, in this case, max row plus row, then I can just be concerned with printing a single row, right? So I can just have one for loop here. I'm kind of separating out my concerns. Print triangle is just concerned with printing the entire triangle, so printing every row of the triangle. And then in print row, I'm only concerned about printing a single row. So in this case, I can say in print triangle or print row, I can do, oh, okay, well, the number of stars I want to print in this case is going to be equal to the row number I'm on. So I could do something like for, I don't know, in this case, doesn't really matter what name I give it or anything like that. So if I want to iterate row times, I could do I is equal to 0 until I is less than row plus I. And then there, I just want to print a single star each time through. And then at the end of the row, I want to make sure that I print my new line character. And here, now I have broken my program into parts. It's a bit longer, but at a glance, it's easier to see what your main does. So instead of having to look at main and see that, hey, it's doing 2 for loops, I can just look at it and say, oh, well, my main's just printing a triangle. And then how do I print a triangle? Oh, well, I have to print however many rows I need of my triangle. And luckily, it's called print row. And then print row, that's concerned with just printing the number of stars and then making sure it ends with a new line. So if I compile that, I run this, print star triangle. Now I can input the number of rows, say 7, and then see that, yay, I did print 7 rows. Input the number of rows, I don't know, 4. You can see that works that time. Again, different way to organize your code. In this case, double for loop probably fine, but you'll see as things get more complicated, you want to probably break it into functions, give it a good name. Naming's probably the hardest problem you will have to solve. And then you go on like that, and then you can actually have a hope of reading this again if you come back to it in a week. So questions about that? All right, so if we are good with that, we are going to get into kind of some rules of these functions, which will motivate us for our next lecture too. So C, it copies function arguments. So in programming languages, we refer to this generically as saying pass by value. So it's saying what happens to the inputs of a function. So for example, in C, if the variable is int, C will create a copy of that int value, and that function gets a new copy of that int value and doesn't change the original one. So what does that specifically mean? So let's get into our example. So what that specifically means is, let's say we have add 2 again, and in here, I don't know, we have, let's just create a variable called int result equals x plus 2. Then we have x equals something like 42, and we are returning result. Then let's say we have main. We define a variable x equals 3. Then we'll print off the value of x. So x equals whatever that value of x is. Then we'll print it before and after this function call, and we will, instead of giving it the argument 4, we'll give it the argument x. All right. So have a good look at this program and tell me what each of these lines print when I'm going to run my program. So initially, remember, we start off at main. So first thing that runs when we run this program, we'll create a variable called x, assign the value 3 to it, print off the value of x in a print statement, then say result. What's the result of add 2? So what's the output of this function given the argument x? And hopefully things are copied by value. And then what is the value of x again? So looking at this, I'll give you a second to read it, and then we can take votes as to what each line will print. And well, I'll give it like a minute. So figure it out. Maybe your neighbor can help you. All right, let's start the easy voting. For the first line there, who thinks that will print x is 1? X is 2. X is 3. All right, good. So we think x is 3. What about for result? Is it going to say result is, result is 3. Result is 2. Result is 5. Result is 42. Okay, we think it's 5. All right, what about this one? Is x going to be 2, x3, x4, x5, x42? All right, we got some x42s. Well, let's see what happens. Oops, it's just let's compile it. And we will, what's it called? Just example. So we get 3, 5, 3. So why is that? It's because it's copy by value. So initially, x is equal to 3. Well, we print off x is equal to 3. It was just equal to 3. So that is what it is. Then for add 2, the input is x. So C is copy by value. So this x in this function, we'll get into what that's called in the next lecture. It's a new scope. So the value of this input here, whatever this variable is, doesn't matter. Whatever value it is gets copied into the input of this function. They don't have to be the same names. I could call this whatever I want. Again, I could call it Z. Doesn't matter as long as it's consistent within here. So it will make a copy. Oops. So this function will get a copy of x, which is equal to 3. And now I just named it Z in the function. Doesn't really matter what it's named. So currently in this call, Z is equal to 3. So int result, that's a new variable called result. Z is equal to 3 plus 2, that's 5. Then we change the value of Z in this function. So that variable is equal to 42, but it doesn't matter. We return result. So the output of this function is 5, which was again 3 plus 2. And then this Z ceases to exist anymore. And we will get into that in the next lecture. So the value of this returns 5. And then x is just whatever it was before. We didn't actually reassign x to anything. Yep.
If you were to return Z, we would get 42 in the third line.
Yeah, so if I did change this to, instead of return result, I return Z, then this line, this result will give me 42. But then I can see my compiler gives me a warning here that says, hey, unused variable, because I don't actually do anything with that result, so I'm kind of wasting time. Yep.
If in the original code you defined x outside of main, you defined it like above main.
Yeah, so if I define it above main, like here.
Yeah, and then you have the original code with the third line print 42 or
Yeah, so the question is, if I moved it here, which we haven't told you to do yet, and we specifically recommend against doing in this course, that is something called a global variable, and we'll get into what that is in the next lecture. But if I do this, x exists for the whole lifetime of my program. So in this case, if I refer to it depends here. So if I have, in this case, if I just say x is equal to 42, then C knows that, hey, this x is that one that exists for as long as my program exists. So it will print x is equal to 3 here, then add 2. In this case, it will return z. So I should just do result. So it will return, in this case, a copy of x, so the value will be 3. So the output of this will be 5. And then it changes the x up here, which now doesn't exist in main. It exists for the whole lifetime of my program. And it will be equal to 42. So if I run this, and I do this, now I see that x is equal to 42 at the end. But even more confusingly, which is why we don't tell you to do this, is now if I change the variable from z back to x and do something like this, now if I do this again, x is 3 again, which is even more confusing, which is why we recommend against it. And I'll explain it in the next lecture. Yeah?
In this course, do we deal with global variables?
Yeah, so in this course, at the beginning, there's a global variable up there is what it is called. It's specifically recommended against because of that confusing thing I just did, right? So I did something that shouldn't change things, but now my result is different, right? If I call this now z instead of x, now my final line is going to be different, which is slightly confusing. And we don't know the rules as to why this is yet. And the rules, especially when you're beginning, is very confusing. And we recommend against doing things like that. But again, I will explain it all in the next lecture. So get ready for that one. So just remember, pulling for you, we're all in this together.